Alrighty, guys, I think we're gonna go ahead and get started. So yeah, just kind of recapping what I was just talking about. I do have you guys unlocked, so if you want to talk, just unmute your mic and do so. If you have questions or anything along the way, I do encourage any questions you guys may have. This class is going to be focused for the installation of PAA coils. So hopefully we get to learn some new stuff here. If you guys are taking this class to unlock PAA coils for you, unfortunately, this is not that class. You'll find that on your Gensco customer account. This one here is going to be focused towards installation for actual installers in the field to answer some of the common questions that we get on these things. So with that, we're going to go ahead and get started. Welcome, everybody. My name is Garrett Vario. I'm one of the Gensco FSRs here. I also do tech support on the phone. So for any of your techs that call in, high likelihood that we've probably had a conversation before. So maybe even on one of these teleheat coils. So what this course is going to cover is we're going to go over what comes in the box. So all the parts and goodies and stuff that come in it. How to convert the coil for your orientation. So whether you're doing a horizontal left, right, upflow, downflow. Condensate connections, how to tie in the condensates, where to put the wires on that. Wiring for your 24-volt controls. Programming your thermostats or your PAC QS445s, and equipment operation of how we're going to test run the system using the control panel on the outside of it. So what's in the box? This is what you guys will get when you open up your coil, for those of you who haven't seen it yet. So you get your coil, obviously, and a goodie bag. On the coil, you also have the thermistors already pre-attached. So you don't need to take those off. They will need to be plugged into the control box, and we'll get through that a little bit more here in a bit. But in your goodie bag here, you're going to get this L bracket right here. What that's for is for filling in gaps in front or behind your coil, depending on the size of your equipment. So that little bracket there is to help out with that, just for fitment issues. You're going to get a float switch that comes provided in the kit. We'll go through that in a bit. You're going to get some wire nuts, your installation manual, a non-adjustable thermostat, CN4F wire connector, which is for the float switch, assorted screws, a return air thermistor, a bracket to hold those two in your return air, zip ties, operation manual, troubleshooting guide, some washers, and depending on your unit, that U-bend covers. So like I said, that's what comes in the kit. What doesn't come obviously is a furnace. You got to provide that yourself, and a heat pump and a line set. Also comes with your control box. So this is mount or comes in the control or the coil box. You don't have to buy this separately. It comes with it. This is the brains of the operation. So this does all the communication and between the heat pump and the coil, and also between the coil and the furnace. So it transfers all the 24-volt controls to DC communication back and forth. And on the outside of it, it also has this little operation panel. So make sure, if you can, make sure that's faced out so it's easily accessible and people can see it on a normal basis. So we'll get into that here in a little bit more. Positioning the coil. These things are designed for all orientations. Horizontal right, horizontal left, upflow and downflow. You will have to do some coil conversions in order to do that, which we're going to go through here right now, actually. Factory configuration. I know this is sitting up. This is actually a horizontal right configuration right here. So this comes from the factory as a horizontal right. So out of the box, if you guys are installing this horizontal right, there is nothing you need to change. It is ready to go. Don't need to pull the doors off, don't need to pull the coil out, anything. Just go ahead and put it in there and get that thing installed. To remove the coil, you'll take the front door off, and then this bracket right down here that I have circled has a single screw in it. Take that screw out, the mounting bracket comes off the coil, and that's the only thing that holds the coil in, so it will slide out at that point. From there, you're going to remove this front panel. So this front cover here comes off with these 5 screws. It'll unscrew from there. When you guys are putting these things back together, I'd recommend just using a screwdriver. Don't use a impact driver, because some of these things are going into plastic connections. So you may end up stripping those out. You don't want to do that. Once you pull that metal cover off, this is what the coil here will look like. So this gives you access to all the inside parts of the coil, which you will need. In order to remove the lower drain pan, there's actually 2 screws in the back side of that coil going through the drain pan from the inside. And there's also 2 screws on the front. One's here and one's right there. In order to take this lower pan off, those screws will have to come out. If you're trying to take this pan off, this lower pan has to come off. So that's how you do that right there. You'll also need to remove this bracket here, which is for the front cover. So that'll need to be taken off. And if you're putting your pan and everything on the left side, this will need to be flipped over to the right. And from there, your pan's able to come off. That's what it looks like there. And you're going to remove this horizontal right drain pan. So has to come out, the bottom pan has to come off in order to get this off. Otherwise, you're going to end up breaking the pans because this thing does sit inside your bottom drain pan. So bottom drain pan must come off before this side panel comes off. Once you get that off, this drain pan will just fall right out. No screws or anything holding it in at that point. It does have these 2 brackets right here that hold the coil up while it's sitting in the horizontal position. If you're changing this thing to horizontal left, those will need to come off and flip to the other side. If you're doing upflow or downflow, these will just come off. Don't need them anymore. If you are flipping these over to the left-hand side, this front panel here has a little V-notch into it right here. The other one does not. That's your indicator that this is the front side bracket. So when you're flipping to the other side, if you get them mixed up, just look for that V-notch. That'll be in the front. It'll flip right over to the right-hand side. Once you get them all flipped to the other side, you'll go ahead and put the drain pan and everything back in. Put the bottom pan back on, and you are now set up for horizontal left. So put your metal cover back on the front of this thing. I didn't do that for illustration purposes, but you will have that metal cover that was on it originally will go back on and in place, and the whole thing will just slide back in. You'll put your clamp bracket back down here and screw that in place if you're done. For upflow and downflow application, that side drain pan and those brackets must come off along with this top plate. So this top plate sits right here. I'll back up 1 slide so you can see it. There it is there. Upflow and downflow, this plate comes off. It's just a couple, I think it's 4 screws, if I remember right. Yeah, 4 screws. Pulls that guy on, it takes off. Horizontal drain pan comes out along with the brackets. Very important you do this for your upflow and downflow application. That way you guys get proper airflow across that coil. If you don't have it there, then you're impeding airflow by quite a bit. You want to make sure we get that removed. Condensate installation. Again, this kit does come with this condensate safety switch right here. So if you guys want to use it, great. If not, and you want to use something else, that's totally fine. Since this kit does come with it, I would encourage you to use it. Use provided safety switch on the secondary port. So our coil, whether horizontal or vertical, you are going to have your primary drain on the left, secondary drain on the right. Your primary drain, just 3/4 inch PVC, just like a normal coil, nothing special there. And run that out to either your condensate pump or a drain or whatever you need to. This secondary switch does need to be adjusted. There's a height change for it. If you take it apart, there's this little nut right here. You want to make sure you have at least 3 rings showing above that nut in order for it to be properly adjusted. Once you get that installed, in your kit comes a pigtail for the CN4F connector. It's got a gray and a white wire attached to it. That is for your safety switch. Okay, so what you're going to do is you're going to wire nut this safety switch to that pigtail. It plugs into CN4F on the board, which I'll show you here in a little bit. And if it does not have that CN4F connector plugged in, or if it's got too many safety switches, or if it's got any 24-volt control wiring going to it, you do not want 24 volts running through that circuit. But you will get a float switch error or limit switch error, depending on what you're using, what it's reporting as. Recommended only one safety switch on that circuit. The way our circuit there works is it sends a 5-volt DC signal through that circuit to make sure that it's actually closed. The more safety switches you add onto that system, the more resistance you're putting on that circuit and have a higher possibility of lowering the voltage on that circuit and fake the system out to think that the safety switch is actually open. So yeah, recommend only one safety switch on there if possible. If you guys have another switch that you want to put on there, pan switch, condensate pump, something like that, I would recommend use that and break your 24-volt controls on your furnace. It won't shut the coil down right away, but the coil will shut down on coil thermistor errors once the fan stops running on that thing. So it will shut the system down eventually. Control box installation. So that control box that comes in the kit, the bed metal box, can be mounted anywhere within 5 feet of the coil. The reason we're limited to 5 feet is because our coil sensor wires are attached to the coil. There's only about 6 feet of wire on that thing, and you want a little bit of slack, and we cannot extend those sensor wires. They cannot be spliced, otherwise you're going to end up with coil sensor errors. So wherever you want to mount this box within that 5 feet is fine. You can mount it on the wall, on the coil itself, on the ceiling, on the floor, in the room behind it. It doesn't really matter as long as it's within 5 feet and those coil wires reach the box so it can be plugged in. Control box installation. So the control box, if you are mounting it to your coil, there is a go, no-go zone. You'll find this in your installation manuals. The little stripe section here, this is where you do not want to put any screws. You run the risk of hitting drain pans or anything like that.
Yeah, for that coil, that PAA coil.
Russ, did you have a question? Just a reminder, guys, you are all unmuted. So if you have your mic unmuted, you are able to talk. We can hear you. So just FYI, if you have any questions, please unmute yourself and speak up. So anywhere within this checkered gray box is where you want your coil to be for screw mounting. It's the same for both sides. You do not want to use longer than 1/2-inch screws. Otherwise, you guys will end up piercing either drain pans or coils. So no 2-inch screws on that thing. 1/2-inch max. In your kit is going to come some washers. Those washers are used to mount the control box. So we want that little bit of air gap. You can see that washer right there. Like I said, it just provides a bit more ventilation to that unit and helps keep the boards and everything inside there cooled off a little bit more. That's what those washers there are for. So if you're mounting it, make sure you put those washers behind it. Control box layout. So if you guys open the cover up to your control box, it's just the 2 screws that hold it on and the cover lifts off. So this is looking at it. Here's your control panel. So that control panel on the outside is actually down here on the bottom of this, underneath this relay board. So what you're going to see when you open that up is you have your main control board here. Behind that is a power board, TBA terminal block, TBB terminal block. So TBA is for your furnace equipment, TBB is for your thermostat. And I'll get more into that here in a bit. Right here you have your TB3 terminal block, which is your S1, S2, S3 that I'm sure we're all familiar with. So that's what the communication is between your coil and your heat pump or your branch box. And then down here we have the relay board. This is where all your 24-volt controls go through and gets translated back to your control board up here for changing it from AC voltage to DC voltage and telling this board what it's doing and what it needs to do. So here's the control board layout. A few of the connectors on here you won't have to worry about. They should be plugged in from the factory. Some other ones you definitely will need to. CN105 connector. I'm sure most of you guys are probably familiar with that one. That's for a MHK2 thermostat, Kumo Cloud, PAC US 445. Any kind of adapter controls that we need to hook up are going to go right there into CN105. If you do have a Mitsubishi wired thermostat, MA controllers, PAR 40s, simple MA, that kind of stuff, the connector for that's right here, but it's actually going to land on the TBA terminal block, which I'll get to here in just a little bit. So this one is factory connected. You don't need to do anything with that. CN20, this one is also a factory connector right here. Don't need to do anything with this, but your return air thermistor that goes into the return of this thing will need to be hooked up to that. Except for where you're going to hook it up to is going to be on the actual terminal block B. And again, we'll get into that a bit. CN4F, this one will be field connected. So this is for your condensate safety switch, that CN4F with the pigtail that it comes with. That pigtail is going to plug into right here. CN4F, that's for your float switch. So that if that thing ends up open, it is going to give you a condensate error. So has to have the switch in there. If for whatever reason you guys choose not to use any of the safety switches tied into the coil, take that big tail connector and wire nut it together. That way it has something closed on there. Otherwise it will not run. CN44, this is for the coil thermistors. So those coil thermistors that are tied into your coil from the factory, that's where they're going to plug into right there. So this is that connector that has to be within 5 feet, or why the control box needs to be within 5 feet of the coil because of those thermistors right there. Control box connections. So these are your inner equipment connection terminals, your S1, S2, S3. Again, just like your normal Mitsubishi systems, 14.3 with ground or 16.3 with ground if you're doing a branch box wire going between the either heat pump to the coil or branch box to the coil. So if branch box, again, should be a 16.3 with ground or 16.4. If you guys do require a disconnect switch, be it on commercial job or local code, make sure you use a 3-pole disconnect. So if you use a 2-pole disconnect, then your S3 or whatever one's not connected will still have 120 volts to ground. So always make sure to use a 3-pole disconnect and don't trust the electrician that they did it right. If you're doing a maintenance or anything like that, service work on a job that has a disconnect and you flip that disconnect, always check voltage to ground. I see it a lot where electricians will only put in 2-pole disconnects and you still have one hot leg. And that can be a real bad day real quick for you. So again, that terminal block is right here underneath the TBB. So that's where your S1, S2, and S3 would go, is right there. So control board connections. So here's your TBA and TBB that I was talking about. So these are the terminal blocks where your 24-volt thermostat wire is going to land inside this cabinet. So TBA is on the right-hand side here. As you can see, TBB is going to be on the left. So if you have a wired Mitsubishi controller, this right here, pins 1 and 2, says M1, M2 on it. That's where your Mitsubishi wired controller is going to land. Everything else on this TBA block is for your furnace 24-volt wiring. So it gives you 2 reds and 2 commons on these things. It doesn't matter which one you use. They just give you extras there for accessories and what you may need. So as long as you have at least one of those connected up, you're fine. You don't need to do any jumpers between reds and commons or anything like that. You'll notice on here, and we'll kind of get into this a little bit later on, but you have a G/Y. So depending if you're using single stage or 2-stage, single stage, you're going to hook G and Y on your wiring. If you're going to do 2-stage, you need to do G and first stage together. So G and Y1 together, and then Y2 over here. Most 24-volt furnaces require the G to be energized in order for Y to work. So that's why we have that down there. Over here on the TBB block, this is for your 24-volt thermostat, or if you're not using that, the non-adjustable stat. And I'll kind of get to that a little bit more in here in a little bit. But just like a normal 24-volt controls, red, common, Y1, Y2, Y, W1, W2, and G. The return air thermistor plugs into RTN and TH01. So that is right all the way down here at the bottom of this block, far right-hand side. Non-adjustable stat and return air thermistor. So this is the return air thermistor. These both come in your kit. So this return air thermistor is what's going to plug into RTN TH01 right here. This is a non-adjustable thermostat set for 65 degrees. So both of these will run into the return air. The return air thermistor again will wire into RTN TH01 on the TBB terminal block. So that's the copper one. Remember, copper is the thermistor, red is your non-adjustable stat. The non-adjustable stat, I'll have some pictures of this coming up here soon, but the non-adjustable stat is going to wire into the TBB terminal block between R and W. And if you have a two-stage gas furnace, you're going to put a jumper between W and W2. This is only used if you're using a Mitsubishi controller. The reason we have that is because the Mitsubishi thermostats, your MHK2s, your Kumo Cloud, MA controllers, those are all still powered by your heat pump and in communication. So if you drop communication or you lose power to your heat pump or anything like that, your thermostat is going to go down with it. So this non-adjustable stat set for 65 degrees will give them temporary heat in that house. So it'll maintain 65 degrees using the gas furnace. So that's why if we have a two-stage, you want to make sure to put a jumper between W1 and W2. That way we can bring that second stage heat on. Do not mix these things up on your TBB terminal block. If you mix those up, you will get a thermistor error. If you try to wire these in together on RTN and TH01, it's going to mess with the thermistor resistance value on there, and you are going to get an error. So make sure that they're separated, make sure you're using the right one. Copper one's return air, red one's your non-adjustable stat. If you're using a 24-volt thermostat, so a third-party stat, your Honeywells, Nest, Ecobees, you do not need this non-adjustable stat because your thermostat will take place of this, and it's using furnace 24-volt power to power that thermostat. So as long as your furnace is still powered on, the stat will be powered up and will work and be in place of this. But if you're using a Mitsubishi stat, this must be connected. Any questions on that from anybody so far? And anything we've gone over? Remember, if you guys have questions, you can unmute yourself or throw it in the chat box there if you'd like. Okay, moving on. Equipment wiring. So this is the TBA terminal block. So the ones in the pictures is on the left-hand side there. This is examples of what it's going to look like if you have a two-stage and single-stage furnace. So single stage, you can see we have our green wire into our G, white into W1, yellow into Y, red and common. Okay. When you come over to the two stage, you can see in this picture here, I have yellow and green, both tied into that G. My black is now on W2 and my brown is now on my Y2. So first stage cooling, second stage cooling. In our application, it just means that we're turning the fan on. Whether you're running the heat pump and you're using heat or cool, it is going to be energizing the Y terminals. It's not going to energize W just because W will kick on the gas heat. We don't want that. So one of the things you guys can do to help clean this up is, we have our G and our Y together here on the G/Y1 terminal block. If you want to do just a jumper inside your furnace and run a single wire to here, so put a jumper between your first stage and fan call inside your furnace, that would work as well, just as long as your G and your Y1 are tied together. Thermostat wiring. So this is terminal block B, TBB. So as you can see right here, this is with the Mitsubishi stat. There's my return air thermistor wired in. This is my non-adjustable thermostat. So that thing has only got just a couple inches of wire, so you will have to connect onto that with actual thermostat wire. And totally fine there, just like a new construction temp stat. If you guys want to change that non-adjustable stat as well, if you don't like 65, if you want to put it to 70 degrees, and you want to get a different new construction bullet style stat, you're welcome to do so. It doesn't matter. But that non-adjustable stat is going to land between R and W. And if you have a two-stage furnace, you're just going to put that jumper wire between W1 and W2. That way, if the stat does call, it'll kick on the second stage heat. By the way, make sure you're putting this on the TBB terminal block. I've seen guys hook this up to TBA and homeowner has the system shut off and it's suddenly maintaining 65. They can't figure out why. It's because this thermostat's controlling the gas furnace and telling it to come on. So make sure it's on TBB. That way it's going through the relay board and only working when it's supposed to. If you're using a 24-volt thermostats or your Honeywell stats, Ecobees, Nest, that kind of stuff, it is going to wire to that TBB terminal block. And it's going to just be like normal color for color. You see right here, I have this set up for a 2-stage. There's my Y2 and my W2. So that's where your 24-volt stat is going to connect. It's not going to connect to a PAC 445 in this application, but the 445 is still required, which is actually right here. So if you guys are doing a 24-volt stat, yes, the PAC 4 US 445 is required to do so. So this is the 445. Does NAT come with the IntelliHeat coil, or to order that separately? The NAT does come with the IntelliHeat coil, yes. So it comes with that 65-degree one. If you guys want to put a different style on there or a different temperature, you'll have to order that separately. So yes, PAC 445, this is it right here. So this is the 24-volt interface you would need for the IntelliHeat coil in order to run a 24-volt thermostat. Same interface as all of our other equipment. So if you have SVZs, PEADs, all that kind of stuff, same interface. This pigtail that comes with the 445 is for the PAA coil. Most guys just end up throwing this away because your SVZs and your PEADs do not require this. This application, it does. So this pigtail, well, first off, the wire on this is for your CN105 connector on the control board. So that'll plug into CN105. This pigtail will wire up to your screw terminals right here, as you can see. And then this pigtail on the relay board plugs into this connector right here. It says 2T-stat, also known as CNH02. So your thermostat does not wire into this thing. I get guys making that mistake. Furnace isn't working because it's not ran through the relay board. It's communicating directly with the furnace. So pigtail to the 445 plugs into the relay board right here. On your relay board, you have a single dip switch bank called SW01. Do not mix this up with SW1 on the control board. So SW1 on the control board is model selection. SW01 on the relay board is for testing operation, and also make sure SW01 switch 1 right here is always on. So what that does, this should be on from the factory. This switch right here allows 24-volt transformer power from your furnace to power your TBB terminal block. So if this switch is turned off and your thermostat's not coming on, that would be why. Either you guys have to wire in your own transformer, or if the transformer in your furnace is plenty big enough, flip this switch on, you'll be good to go. Usually I'll see you guys flip this switch off and wire their own transformer if they're doing a zone system or something like that. So again, should be on from the factory. I have seen a few of them come set off, so just make sure that that is turned on. You'll also need that power supplied to the non-adjustable thermostat. So like I said, there's really, unless you guys are providing your own transformer, there's really no reason to have this switch off. It should always be on. Here's a wire diagram that we made because the wire diagram in the book is not very good. If you guys had a one of our Gensco Tech manuals, you'll find this wire diagram in there. But as you can see, this is kind of the wiring for that. So our furnace controls, you see in the book, we have a jumper between G and Y1 in our furnace. So your furnace wires up to TBA. Your thermostat, as you can see, wires up to TBB. Your PAC 445, there's the harness for it right there. This does not come installed in the box. Looks like we did that, but it plugs into right there on the relay board. There's that SW01 dip switch I was talking about. And then your connector for CN105 plugs into the control board right there. So again, if you guys have one of our tech manuals, you'll find this wire diagram in there, along with a bunch more information for PAA coils and everything else. Marvin, I seen you have your hand up. Do you have a question?
Yeah, so my question is, where, how can we get one of those Gensco uh,
Tech manual?
manuals? Yeah,
A couple ways you can get them. You can download it yourself from Gensco Customer. So if you go up to technical on your Gensco Customer, you'll find the tech manual in there. Or talk to your outside sales rep. They can get you a hold of some of those manuals if you need them. Or if you guys are attending any of our trainings or M&P classes, we hand them out there as well.
okay. And a secondary question.
Yeah.
So the wiring for the thermostat, we don't have to do any of that wiring if we're just going to use HK2, which I'm guessing is compatible with this.
Correct. Yep. So yeah, if you're using just the Mitsubishi thermostat, the only thing you need to wire in on the TBB terminal block is going to be the non-adjustable stat. So you won't have to worry about this 445. You don't have to worry about the 24-volt wiring over here. It's just going to be that non-adjustable stat right here.
Awesome. Thank you.
Yep. And it looks like Jason Phelps commented. Jason is one of our service reps, our high efficiency specialists up in the Seattle area. Him and Jonathan have them in their office. So if you guys reach out to them or if they're coming out to your guys' job site and you would like a copy of those tech manuals, let them know and they'll get you hooked up with that. So 24-volt stat interface setup. Thermostat must be programmed as conventional gas furnace with AC. Do not program it for heat pump or dual fuel. I see you guys making this mistake all the time and the system doesn't like it. It doesn't work correctly. So your thermostat, make sure you program it for either single stage or two-stage gas furnace with AC. We don't want it set up as a heat pump. If you have one of the PAC 445s, all your function settings or your economic balance point, your fan settings, all that kind of stuff is going to be done using these dip switches right here in the 445. In order to get this cover off the 445, you got to pull these 4 screws out on the back side, and then the whole front cover comes off. These dip switches, they're going to need to make sure that they are set with power off. So before you even power the system on, you guys should be setting these dip switches. So same thing on SVZs or any other of our equipment that you may be using these things on. These dip switches are going to need to be set up. The only exception to that is if you're using city multi-indoor equipment, all your function settings of those will be done using dip switches on the equipment. But everything else, these dip switches will need to be adjusted. So make sure you look at your installation manual for the PAC 445 and whatever your system requirements may be for that. One of those dip switch and function settings you guys are going to need to do is setting the economic balance point. The economic balance point is the outdoor ambient temperature of which the system switches over from heat pump to gas furnace automatically. So that is adjustable. Economic balance point can be set through your MHK2 using modes 8 and 10, which is normally for static pressure settings, but because we don't have control of the fan static, those settings have been repurposed for the economic balance point. So you'll find this chart right here in your PAA Coil Installation Manual. Look under the economic balance point section. So if you have a standard furnace, these are your options right here. 32 degrees, 27, 19, furnace only. So if you guys are using a PUY, cooling only outdoor unit, you're gonna wanna make sure to set this to furnace only. That way it doesn't try running the heat pump. 14 degrees and 9. And then for your extended balance points, this right here is if you have a hyperheat outdoor unit, your balance point changes. So you can go all the way down to -11 with that. So again, this would be set up through your MHK2, function code 8 and 10. And you'll find this in your install manual for the PAA coil. If you're using a PAC 445 and you're using dip switches, you're going to need both of these charts pretty much. Because you need to know what function mode do you want to set your temperature to and which dip switches do we need to set to do that. For example, if I want to set for 32 degrees, which default, but PAC 445, you have to turn them on anyways. But if I want to do a 32 degrees changeover balance point, then modes 3 and 2, or mode 8 would need to be set to 3, mode 10 would need to be set to 2. So you come over to your chart here, mode 8, 3, mode 10, 2. That tells me my SW2 switch 1, 2, and 3 should all be on. And that is this dip switch bank right here. So if I wanted to make it furnace only, mode 8.2, 10.1, 8.2, 10.1, SW2 only would be on, SW2 switch 2. So if you guys, like I said, if you're using the PAC 445, very important, you make sure to set these up. If you don't, the system does weird stuff. Fans don't want to run, system doesn't want to work the way it's supposed to. It's going to do crazy things. So this is one of the things we usually check on the phone if you guys use, if you're using 445s. Make sure your balance points are set up. Function settings for single stage and two stage furnace. You have to tell the IntelliHeat if it has a single stage or a two stage furnace. So again, if you're using a thermostat MHK2 or Power 40, it's going to be function setting 23. Setting 1 is going to be for your single stage. Setting 2 is for your two stage. PAC US 445 is SW2 switch 4. Or unintelligible. Yes, the instructions on the 445 can be very confusing. Hopefully this is helping you out a bit. So if you have a two-stage, SW2-4 needs to be turned in the on position. If you guys don't do this and you have it set up and wired for a two-stage and you don't flip this switch on, you are never going to get W2 or Y2 to turn on. So you're always going to be running a low fan speed and you're going to have cooling and capacity problems. Okay, so very important if you're using two-stage, make sure to program these things. You know, I see some guys that don't know about this and just do jumper wires from Y1 to Y2. Honestly, you're probably better off doing this route. It's really easy and you get more functionality and efficiency out of your equipment. So if you can, do this instead. Static pressure. So static pressure, again, cannot be programmed by dip switches or function settings on either the 445 or Mitsubishi controllers. So it has to be done through your furnace. Static pressure must be set on the furnace settings. Refer to your furnace operation or install manual for that. So right here is a chart for different coils in the rated airflow of what you want to set your airflow to. So make sure you pull out your install manual. Hopefully you still have it, or service manual, or try to find it online. That way you guys can see what to set your airflow to. If you're doing a downflow application, do not exceed 350 CFM per ton, or you will be blowing water off that coil. I had one of these things just recently, 3-ton system, water blowing off in the base can. I asked them what was your airflow set to. They said 1200 CFM. Well, 12 times 3, that's 1200 CFM. Max in that situation would have been 1050. So they had airflow issues is what was causing that to happen. So it's not just a recommendation, it will blow water up that coil, guarantee it. So again, this little chart right here, you will find this in your installation manual. And downflow, very important. Do not exceed 350. Control box operation panel. So that little panel on the outside of that box. We talked about a little bit earlier, but I'm going to go into more detail now. Make sure that that little panel is accessible if you can. Make sure to point it out to a easily seen spot. Make it conspicuous because it will tell you quite a bit of information, believe it or not, with just a couple of LEDs that it has. So if you're using a 24-volt thermostat and your IntelliHeat controller is in error, this is the only way the customer is going to know that. Otherwise, they may be running gas heat without even realizing it. They're not running the heat pump because there's an error on the system. I see that fairly often on 24-volt controls, customers complaining, hey, my furnace always seems like it's running the gas. It doesn't seem like it's running the heat pump. Find out what this little LED panel is doing. If it's lit green, then your IntelliHeat is in normal operation, no error. If their gas furnace is running, it could be because of the economic balance point or the comfort balance point. Comfort balance point, it'll learn at what ambient temperature it takes to heat the house, and it'll automatically switch over to gas furnace. Or if it's been running for more than 20 minutes without a temperature change, it'll switch over to gas furnace. So you'll see gas furnace running, normal operation. If your gas furnace is running and you have a red light right here, emergency mode, that tells you the system is in error. Okay, so if that's the case, you need to go look at your heat pump, start trying to figure out what is the error, look for any codes on the thermostat. If you have an MHK thermostat or a Mitsubishi thermostat, take a look there, or go look at your heat pump, any error codes out there. Test mode, if you have a yellow LEDs lit right here in your W1 test mode, yeah, that means you're in test mode. SW01 switch 4 is on, and you're able to run that system using W1, W2, which I actually have coming up right here. So in order to use that test mode, you're going to power off the heat pump and the furnace for at least 3 minutes. That way it has time for everything to bleed down capacitor-wise. You're going to set SW01 switch 4 to the on position, and then power the furnace only. So this is if you guys are wanting to test the gas furnace to make sure that the gas is actually working. Once you power the furnace back on, this panel here should light up and you should see the test mode button here, or LED is lit up. Okay. From there, you have the W1, W2 buttons here. So if you have want to test your first stage gas furnace, press W1, verify if the fan kicks on and the furnace kicks on. That's your second stage. If you have a second stage, then if you press W2, it'll kick on that second stage heat. And then to turn them back off, hit right here, W1, W2 off. That'll turn it back off. And then from there, you can power the furnace back off, change your SW101 switch to the off position, and then restart the system. You're back in normal mode. So if you guys are using this test switch to test your gas furnace, make sure you turn it back off. You don't want to end up with a service call going back out there because the system's not operating properly and it's just running gas only. So seeing that happen, guys will be testing it, forget to turn it off and walk away, and then come back a couple hours later because the customer's upset. That's what I have for you guys so far. Anybody have any questions on anything? Anything I didn't cover? Anything you want to see added to this? This is our first time doing this presentation, so like I said, I'm open to feedback from you guys if you want to see anything added to it or want clarification or anything.
Are you able to hear me?
Yes, sir.
Any functionality that you get or don't get just by using the Mitsubishi thermostat versus a conventional one?
Yeah, so functionality wise, you're gonna end up losing like dry mode, which most people don't use anyways for a little bit of dehumidification. The other thing you're gonna lose is the ability to see any error codes on the system, which is always a big bummer, and also full communication with the heat pump. So one of the things you're going to see if you're using MHK2 is your system doesn't know what the set point is, so it's going to make one up that's below its current target. So the PAC 445 will make that, it'll look at the return air thermistor. It's actually one thing I want to talk about. Thank you. If you're using a PAC US 445 on the IntelliHeat system, or any Mitsubishi system for that fact, your system is no longer in communication with the stat, so it doesn't know what the return temperature is. So it relies on that return air thermistor. Okay. So it's looking at the return air. If you are in cooling mode and your return air temperature is below 67 and you're calling for cooling, the system will not turn on. 67 is the lockout. It's the safety for the system to make sure it's not running too cold. So if you guys get in a service call, usually in the spring and falls, we'll see this, or if the furnace is like in a crawl space or a basement, garage with a heat pump water heater sitting right next to it, and you can run the system in heat, but when you switch over to cooling, it doesn't turn on, check your return air temperature. Make sure it's above 67. If it's borderline or if it is below 67, hold that thermistor in your hand to warm it up and see if that thing turns back on. Okay. So yeah, as far as functionality loss goes, there is going to be a little bit of functionality. Honestly, I've been seeing quite a few issues lately with newer thermostats. to where I don't really even recommend them anymore. If you can, I would stick with Mitsubishi controls. What I've been seeing happen a lot on newer thermostats is they're not using real relays in those stats anymore. They're using a triactor or a digital relay. So even if what I'm seeing on those is bleed by voltage happening. So, bleed by voltage under your G terminal or your W terminal, just enough to screw the system up and confuse it. So even if it's not calling that terminal, if you disconnect everything and measure voltage, I usually see around 10 volts on the unused terminal, which is enough to mess with the system. So if you guys do come across that, your only options are going to be is Mitsubishi thermostat, get rid of that 24-volt interface, or put in isolation relays in all your wires in order to eliminate that problem. So just something to be aware of if you guys are on site. If you can, encourage the customer to go with the Mitsubishi stat. Will this be updated PowerPoint and Gensco Tech Manual and Gensco Customer? Yes, hopefully we will get this uploaded to our Gensco customer account. That way, if you guys want to come back and have more of your installers or anybody sit down and watch it, it will be there and available for you. Was that able to answer all your questions for the PAC 445?
I have one more. Right at the beginning, you mentioned something about I was fiddling with my equipment, but unlocking or opening up the ability to purchase.
Yes. So in order to purchase the PAA coil, this class is not for that one. So if you go to your Gensco customer training videos, you'll find the other PAA webinar on there. That's the one you're going to need to complete in order to get the equipment unlocked for purchase. This one is just focused for installation and help out installers.